Hello everyone and welcome to the Advanced Numbers lecture. So in this lecture we're going to go over a few more representations of numbers in Python and then a few of the built-in methods that have to do with numbers in Python. It should be a pretty brief lecture but an interesting one. So just going through the Jupyter Notebook, we're going to look at hexadecimal representation of numbers, binary representation numbers, and then a couple of built-in arguments, or excuse me, functions for numbers. So in case you're not familiar with hexadecimal formatting or binary formatting, I went ahead and linked the Wikipedia pages for both those formats, and you can check them out as far as the descriptions and how they actually work here. So I won't be teaching you what hexadecimal numbers actually are, what binary numbers actually are. You can go ahead and read about that on the Wikipedia page yourself. So I figure these two topics are only useful if you're familiar with the computer science topics or in your math classes and we're curious on how to do it in Python. So quick overview on how to do them in Python. For hexadecimal numbers, you can call the hex built-in function, and it will convert numbers into the hexadecimal representation of numbers. So for instance, if I call 12 there, it returns the hexadecimal representation of that number. And let's just do another one, such as 512, and there's another representation of it. If you're interested in binary representation of numbers, you can use the bin function, and that will return the binary representation of some numbers. So for instance, if we just go for some classics, such as 128 or 512, you can see those are the binary representations of those numbers if you're familiar with binary representation. Okay, now let's go over some more common built-in functions. So we know that we can call to the power using two asterisks, but there's also a function for that. So you can call POW and it will do the same thing. If you put in 3 arguments, such as this, what will happen is the third argument will be treated as a mod. So with 2 arguments, it's the equivalent of x to the power of y. X and y are your first and second respectively. But with 3 arguments, it's equivalent to x to the power of y mod z. And this just has to do with some efficiency cases, in case you're interested in why there's a whole built-in function for that. Now, there's also an absolute value function, which is ABS, which will return the absolute value of a number that you put into it. There's also the round function, and it will round the number to a given precision in decimal points. And by default, it's 0. So if I wanted to round, let's say 3.1, it would round it off to 0 decimal points. So for instance, to make it clear, if I also put in just 3, it rounds it off to 0 decimal points. Or if I put in 3.9, it rounds it off to 0 decimal points here to just 4. Okay, interesting to note though, it always returns a floating point number, which is why you're seeing that 0.0 there. You can also specify how many digits you want after the decimal point. So for instance, if you had the longer representation of pi, let's say you only wanted to see 2 decimal places past the points, you can add that in as a second argument. Okay, that's really all there is for the advanced numbers. Should have been a pretty brief and straightforward topic. Main takeaways are there's the hex and bin functions for you in case you're interested in that. There's also these built-in functions, abs and round, and also pow for power. And Python also has a built-in math library, which may be useful to play around in case you're ever in need of some more mathematical operations. Okay, and as always, here's the Jupyter Notebook that goes along with this lecture for you to check out. All right, thanks everyone. I'll see you at the next lecture.